They're both not the time. What are you talking about?
Team song.
You $10. It's a boxing match. You gotta go double digits. At least push it to 5.
If we watch the game, so not
Yeah, you can start.
Oh, if that happens, I'm not. They do like $80.
Do you have my birthday? You do? You love me.
User asking.
Give me your
Oh,
bucks.
yeah, that's good.
I get hard. What's this one?
Okay, we're gonna get started, everyone. Thank you. Hello, hello, hello. We're getting started, everyone. Okay, so to start off with this one, you really should take a look at what you have. We have 0 to 6, 0 to 2, 6 to 2. So this is definitely backwards. So it should be 2 to 6, but it's now 6 to 2. And we're going to try and make an equation out of this. And so the equation that you're probably going to choose is 0 to 6 of f of x is equal to 0 to 2 of f of x plus 2 to 6. Okay. Yeah.
If you switch the 6 and 2, aren't you making
Yeah, you are.
Is it minus?
No. This is still a true equation, isn't it?
Oh yeah.
Yeah. So we're just making this true equation if we can. We know 0 to 6 is 6. 0 to 6 is 6. We know that 0 to 2, I'm looking for it, is -3. And now we're just left with the one unknown integral, which you should feel comfortable manipulating using some algebra. So using some algebra, if you add 3 to both sides, you'll get 9 equals the integral from 2 to 6. Therefore, the integral from 6 to 2, that's going to be equal to -9. Because if 2 to 6 is +9, 6 to 2 is -9. Okay, let's look at 34.
Wait, can you scroll up first, please? Thank you.
Okay, Guess I'll wait here for a couple seconds, a couple minutes. Oh man, I need this closed. I can't have it near me.
Okay, that's good. Thank you.
With the card.
Now I have a new container. 34. It says use fundamental theorem of calculus, but that really just means that you have a definite integral. So you have 1 to 3, and I'm going to really quickly turn that x into x to the negative 3, because we're trying to, that's not too much of a simplification. And then you just think negative 3 plus 1 is negative 2, right? From 1 to 3. So that's negative 1/2, 1 over 2x squared. Oops. 2x squared. No. 1 over 2x squared from 1 to 3. So that's equal to negative 1 over 2 times 9 minus negative 1 over 2 times 1. So what is that? 1/2 minus 1/18? 9 over 9. 9 minus 1 is 8. 8 over 18. You know what? I'm going to change that order back around because I think that's confusing. It's 9 over 18 minus 1 over 18. That's 8 over 18, which my division's horrible. What is that? 4 over 9? 4 ninths, which is 0.4444. Pause here for a second, wait for questions if you have any. This is a good question for you, or this is a good problem for you, right? Hopefully. Okay, 35. This is just evaluate, or in this case, you want to find the antiderivative. What is the antiderivative of cosine x over 4 dx? Now, I saw in a couple of quizzes yesterday that when they had something like this, or when they integrated something like this, composite function, they forgot to make a u substitution. And we've been getting used to doing these so quickly in our head that we have to remember that this integral must be done with a u substitution. So du equals 1/4 dx. 4 du equals dx. So this integral becomes the integral of cosine u 4 du. Integral of cosine is sine, so this is 4 times sine u and the constant, which is 4 times the sine of x over 4 and that constant. You're so lucky. She's teaching at Pierce. Hmm?
Do you want to teach English?
I wouldn't mind teaching a night class of math to a bunch of ding-dongs. Whatever. It's money. I mean, what else am I going to do? Well, I'm going to Koreatown tonight. Seeing a concert. We'd have to come. I have an extra ticket. Ryan Adams. Ryan Adams. I didn't think you did. Nobody likes him but me, apparently. Ooh. I think I better fix this.
I didn't. I did. The whole test I was leaving. The washer is what it is. I just went with the washer, but to be safe to get some points, I got the area you can. I got 21. One of my anti-derivatives were 1 over 272 x to the 7. You have to have. Yeah. That's a good. That's a good. We're a bit negative. It's a washer. It was a cylindrical shell. I solved it in terms of a washer. No. I got 21. I saw it. I didn't solve it. I think we just tried to. I think since we baked on it wrong, it was a cylindrical washer. That's good.
Okay, let's move on. Were there any questions on 36? Anything else on 36 you want to look at? No? Okay, good. Let's go to 37. Yeah.
How do you know what the cross section looks like?
Because it says it's supposed to be a square from a typo. There was a typo and it should have said square, but it doesn't.
You're just jealous.
Okay, let's take a look at 37. 37. Find d squared y dx squared. Oh, I feel like we're going to be in for a long haul on this one.
No. Should I start a new page?
You might have to. Okay, so we're starting off with y, and that's equal to x plus 2 over x minus 3. And hey, would you be using the product rule or the quotient rule here?
It's a minus 3. Yeah.
You don't want to use the product rule? You'd rather use the quotient rule? Okay, we'll use the quotient rule.
Can we write down
All right, let's use the product rule first. Product rule. No, the quotient rule. Sorry, quotient rule. Erase, buddy. Erase. Yeah. Quotient rule. Okay, so that's x minus 3 over 1 minus x plus 2 times 1 over x minus 3. Actually, this is a pretty good quotient rule. It's not. We don't really need to use the product rule. Yeah, I'm supposed to square that denominator. You're right. Okay, and so what do we got? X minus x is 0. Minus 3 minus 2 is negative 5. So this becomes negative 5 over x minus 3 quantity squared. Is everyone okay here with dy dx?
Should we
Next, we're going to use the quotient rule again. We take the derivative. Yeah, we could use the product rule, but I think we're going to stick with the quotient rule because that's kind of how most of you would probably do this. Believe me, it's probably smarter to use the product rule here.
So let's just do it. Just show us. Yes.
No shit,
Gonna stick with the quotient rule here. This is equal to. Hey. Two x minus 3 1 over x minus 3 to the 4th power. Okay, well, good. This whole thing cancels out. We have 5 negative, so positive 5 times 2 is positive 10. So that's 10. One of those x minus 3's cancel out. That's x minus 3 to the 3rd power. Actually, that's not that bad of a quotient rule. Sometimes it goes horribly wrong.
Yeah, where's the 2? Is it square? Isn't it negative?
No, it's positive.
Really?
Where did the 2 came from the power rule? The derivative of x minus 3 to the 2nd power.
Oh. Oh.
Is that squared or cubed? It's cubed.
As the final.
Times 1, yeah. 1 is the
We lost
derivative of x minus 3 because you're using a chain rule.
oh right. So 2 comes to
Negative 5 times 2 times what?
Okay, the next few questions are calculator questions. Remember, that doesn't necessarily mean you have to use a calculator. It just means that you have the option of using a calculator should you need the calculator. Number 1 is a calculator question. We have dy dx equal to x minus y. We have y equals 2 and x equals 2. We're supposed to use increments delta x equals negative 0.1. And we want to find f of 1.7. So we're going to have to do this, I think, 3 times. Let's make a chart.
Yeah, but it's just a chart. It's not that hard.
Okay, so we're going to start with x and y. And then I think we're going to have delta x. Then we'll have dy dx.
Wait, was it? I like the idea. Yeah, do I?
Then we'll have delta y. Then lastly, x plus delta x. Y plus delta y. Okay, let's start off with xy. Our xy is 2, 2. Delta x, we're told, is negative 0.1. Negative 0.1. Dy dx is going to be 2 minus 2. What's 2 minus 2?
0.
Yeah, it's 0. 2 minus 2. 0. Delta y, if you remember what delta y is, I didn't write it down here, but that's going to be m times delta x. So 0 times negative 0.1 is 0. X plus delta x is 1.9. Y plus delta y is 2. And are we done? No, okay. 1.92. Delta x is still negative 0.1. Dy dx is x minus y, which is 1.9 minus 2. 1.9 minus 2 is negative 0.1. Good. Negative 0.1 times negative 0.1. 0.01. Good. Okay, 1.9 plus negative 0.1.
1.8.
1.8. 2 plus 0.01.
1.99. Oh wait, 2.01. 2.01.
Are we there yet?
Almost. One more.
Okay, x minus y, 1.8. I better do this here. 1.8 minus 2.01. It's a good thing we have a calculator. 0.021. Hey. Man. Okay, and what's next? M times delta x, that's negative 0.1 times negative 0.21. Ooh, positive 0.021. Cool. 1.7, and let's see. 2.01 plus 0.02 is 2.03, so it's 2.031.
Yeah.
Are we there yet?
Yeah.
Good.
Okay, so that was.
Alright, so f of 1.7 is approximately equal to 2.031.
Looks like it's negative 0.1 minus. Is that what?
Okay, questions on this? Good, let's move on. Number 2. Find the general solution to the differential equation. Oh, look at this. Lucky for us we have our calculator. Oh wait, the calculator doesn't help very much on this question. Okay, so let's take care of this. We have dy dx equals 2e to the x plus secant x tangent x minus the square root of x. And okay, so we need a general solution. That really just means integrate. Okay. And we'll integrate now. Integrate everything. The integral of y is dy is y. The integral of 2e to the x, 2e to the x. The derivative of, the integral of secant x tangent x. The integral of x to the 1/2. Okay.
That's it?
Plus c, thank you.
Mr. Berry, on the test, are there going to be some answers without a plus C to throw us off, or would that just be a typo?
It's possible that you'll have one without a plus c. Just to mess with you.
So if they're like, this isn't thing with a plus C or without a plus C, but big throw in plus C.
Yeah. Possible. Question 3. Car moving with an initial velocity of 5 miles per hour. Oh, maybe we should write that down. V0 is 5. V of 0 is 5. Okay, what just happened? Velocity at 0 equals 5. The acceleration is 2.4 t. I think I need an equal sign there. For 8 seconds, how fast is the car going after 8 seconds? So I think that's asking for the velocity, right? The velocity at 8 equals question mark. Good. Oh, this is not that bad because velocity is equal to the antiderivative of acceleration of t. Right? Okay. And so this is equal to the antiderivative of 2.4 t. Okay, what's the antiderivative of 2.4 t?
1.2, yeah. 2 squared. Plus c. Plus
Good. All right. What is the value of that c?
5. No, no, no. No, it is 4 times.
So the constant is equal to 5, right? How do I get the velocity at 8? Plug in 8, good. 1.2 times 8 squared plus 5. Oh, we have a use for your calculator now. 8 squared is 64. 64 divided by 5. 64 divided by 5 is 12. Because I'm gonna add 2/5. Or 1/5.
It's 81.8. Yeah.
Fine. One is
And there's the 76.
It's the 0 cancels out 1.
64 divided by 5 is equal to 1,
That's 12.
2.8. 80. No. Yeah, no. 64 plus 12.8.
Wait, why did you do that? What's the point of that? Why did you just ask?
76.8.
You are wrong. How are you guessing?
Okay, wait, hang on. Hang on. Allow me to explain. Okay. 1.2 times 64 is the same thing as 1 times 64 plus 0.2 times 64.
Yeah, but like,
That's okay, but why
so why would you do that?
Okay, 0.2 times 64 is the same thing as 1/5 times 64.
Yeah. Well, we know.
But like,
Well, I think
1/5 times 64 is the same thing as 64 divided by 5.
okay. So why do we do it?
Therefore, 64 divided by 5 is 12.8. Therefore, 1.2 times 64 is 64 plus 12.8.
Plus 5.
Plus 5.
Plus 5.
You don't have a calculator per se.
It's okay. The answer is 81.8.
I do.
That's so funny.
Now, I'm not sure why it says 76.8.
I think that's because that's without 5. It's an extra 5. So you probably just forgot the plus.
Oh, because of the plus 5. 76.8, yeah. So I have to fix that. That should be 81.8. Remind me to fix that.
Remind you to fix that.
Fix it. I'll fix it. What does fix it, Fred? Fix it, Felix say? I'll fix it.
Fix it, Felix. I'm gonna fix it.
I'm gonna fix it. Yeah. Question 4. Question 4.
You're skipping the back one?
Oh, no. I'm sorry. Question 3. Question 4. We're going to use a trapezoidal rule with 6 subdivisions. And we're going to go ahead and do it. Okay, so we have, I'm going to start off by making my intervals of x. My intervals of x, and then, I'm going to, okay, so my intervals of x are 0 to 4. 4 to 8. 8 to 12. 12 to 16. 20 to 24. Good. That's very nice. Next, we're going to get our delta x, which is our base, right? They're all 4s. Now the height. Now this is going to be the tricky one. The height's going to be equal to 1/2 what is this? RL plus R on the right. Okay, so the average of 0 and 4. What's the average of 9.6 and 10.3? (9.6) plus 10.3. Not yet. 9.95. Okay, good. The next one is the average of 10.3 plus 10.9. 10.6. Okay, cool. Next one is the average of 10.9 and 11. I forgot the multiply sign, that's why. 10.95. Hey, you knew that already. I feel like my chart's going to run out of room here. It's 11.1? Crud. So it's just 11, right? I'm getting worried about my chart. We better just do the rest of these. Okay, the average of 10.1 and 10.9. 11, right? The average of 10.9 and 10.5.
No.
It's 11.1.
It's 30. Oh, 11.
Yeah, 11.1 and 10.9. I was like, where's the 10.9?
Average of 10.5 and 9.6.
10.05.
That's the last one. Yeah,
10 point 10.05. All right, so I'm gonna have to believe you on all those.
That's 11.
All right, so that is one heck of a chart there, right? Okay, and let's go ahead and get the integral then. Let's evaluate that integral. So we're going to have the integral from 0 to 24. It's going to be equal to 4 times 9.95. 24 plus 4 times 10.6. Maybe I should put the x's there instead. Plus 4 times 11 plus 4 times 11 plus 4 times 10.7. That is ugly, sorry. 4 times 10.7 plus 4 times 10.05. It's a good thing you have your calculator. Point. Point what?
What if it wasn't the same number?
Could you pull up the 4 and add the number?
You could have. You know, I'm not really here to tell you how to do algebra. So if you can find a way to algebraically do this and do it algebraically correctly, it's a big key right here for you. Make sure your algebra is correct. So yeah, you could absolutely factor out the 4 if you wanted to. I have no problems with that. Any other questions with number 4? Number 3? We're on number 4. Keep up. We already answered that question.
I finished number 4. Oh, we forgot gallon.
Okay, are we finished with number 4? Okay, number 5. Number 5 says, suppose the rate of flow of water is approximated by QD 0.01950 plus 25x minus x squared. Find the average rate of water usage over a 24-hour period. So that just sounds like we're supposed to integrate. Sorry, we're supposed to go 1 over 24 times the integral from 0 to 24 of QT dt. Now, there isn't any reason why I should have to write this entire thing. This is a calculator question, so let's do this with a calculator. Yay! So we're going to take a look at a fraction. Fraction 1 over 24, never mind the 25, times the integral, green F1, times the integral from 0 to 24 of QD, 0.01 times quantity 950 plus 25x. Where's the X button? (25x) minus x squared. I don't know where the square is. Is it here?
Oh goodness. What happened?
Square is I.
It's under the X and
Dx. Did I mess up somewhere else?
No. Do you need to add another?
I do need another parenthesis.
You put DX.
My calculator is like this.
Okay, do I have any other problems? Good?
How do you do with the commas? Because my calculator is in parentheses, so with the
Function, comma x, comma a, comma b.
here, let me write it. So f, because it goes fn, and so it's the function, comma x, comma a, comma b.
Good. All right. That should just give me the answer right off. It's 10.58. The average amount of water used is 20. The average water rate is 10.58. We don't have any units, so 10.58 will have to suffice. 10.58.
Yeah.
Question 6. The solution of the differential equation dy dt equals ky, where k is constant and it satisfies y0 equals 100, k equals 1.5. Hopefully you recognize that as a differential equation for exponential growth. In which case you can just go ahead and go automatically to y equals a e to the negative kt. However, if you don't remember that, or if you did not memorize that, then you're going to have to integrate this by hand. And aren't you lucky? To integrate this by hand, dy dt equals k times y. dy dt equals k times y. Moving on. dy over y equals k dt. Ooh, what's all this from?
Scroll up for 2 seconds, please.
What is all that? That's number 10? Okay, we'll have to deal with that later. Hang on, give me a second, I gotta fix this. I'm gonna fix it. I'm gonna fix it. I did not fix it. Oh, I missed. All right. I paid good money for this tablet. I better use the tablet. That's not a lasso. Lasso. Okay, I'm gonna fix it. We fixed it. Okay, let's integrate. I'm gonna integrate the left, I'm gonna integrate the right. A little bit of this, a little bit of that. We're gonna get a natural log of y. Shh. Calm down. Equals kt plus c. Let's remember that y is positive because it's a population, so we don't have to deal with the absolute values. Therefore, the natural log of y is equal to kt plus c. Exponentiate, and you get y equals a e to the kt. Please don't ask me why it's a and kt and where's e to the c. That's all review. I hope you remembered how to do that. A to the kt, e to the kt, I'm sorry. And next we have an initial condition, y0 equals 100. So if y0 equals 100, that means y0 equals a times 1, which is equal to 100. Clearly a is equal to 100. A equals 100 e to the kt. Oh, k is 1.5. 100 e to the 1.5 t. Yeah.
Why is 0 equal to a of 1?
When you substitute 0 here, you'll get e to the 0 times k. Hey, that wasn't bad. Yes.
When do you know when you take the integral of
I really can't hear with like two conversations going on at the same time.
when do you know when there's absolute value around the y for the ln y?
Okay, the point in this question was there's always an absolute value.
Okay.
Always. The reason why we can get rid of the absolute value in this case is because we know y refers to a positive quantity. Mm-hmm.
I thought the equation is e to the negative kt.
I think that's if you start off with negative ky over here. Okay. You also might be confusing it with the Newton's law of cooling equation.
Possibly.
Let's move on to 7, huh? Radioactive element has half-life of 50 days. What percentage is going to be left after 60 days?
That's not number 7.
Number 7, a mold culture doubles its mass every 3 days, exponential growth. Find the growth model for the plate seeded with 1.2 grams of mold. That's awesome. What does that even mean? It means we're starting off with 1.2 grams of mold. Man, mold is...
A lot of mold. A lot of mold.
Is that a lot of mold?
That's disgusting.
That's more than 1.2 grams too much.
Well, what if it's penicillin? What do you mean no? Penicillin is like amazing.
I think I'm allergic.
Okay, so let's start off with the growth model. Y equals a e to the kt. We need to figure out k. Oh, we're told that we're seeding with 1. What did I say? 1.2 grams. 1.2 grams of mold. So that actually is 1.2 e to the kt. Let's get a value for k. Okay. We know that after 3 days, we're going to double our amount, right?
Yeah.
So that means that after 3 days, we're going to have 2.4 grams of mold. After 3 days.
Yep.
That means 2 equals e to the 3k. Natural log of 2 equals 3k. And therefore k equals 1/3 the natural log of 2. I'm way off in the margin now. Oh, did. Trying to bring it all back. Okay, there we go. There we go. What did happen to the kid?
You forgot.
Where's the kid? Oh no, it's gone. We separated the kid. Now it's nothing more.
How's that? Okay, we have that. I'm going to just leave that for now. I'm going to put it in the calculator later. We want to know how much, what percent, no. Oh no, that's it, right? Let's get a value of k. What is it? 0.2310. So we have y equals 1.2 e to the 0.2310 times t. That's great. That's really cool. can't even tell if that's a fast-growing mold or not.
It's mold and it will become a the question is, will it become common?
Question 8. Question 8. We have a radioactive element has a half-life of 50 days. Okay, so I don't actually have this memorized, so I'm just going to go ahead and write down, first of all, the general exponential growth and decay model, which is y equals a e to the kt. And if half-life is 50 days, that means that 1/2 of a equals a e to the 50k. That means, now, hopefully I won't have to solve this too, no, I better solve it slowly, I know you people. That means that 1/2 is equal to e to the 50k. That means that the natural log of 1/2, please with the conversation, is equal to 50k. The more time I have to spend telling you to shut up, the longer we're going to be here. That's equal to 1/50th natural log of 1/2. That's going to be my k. How much is left after 60 days? Okay. And it wants what percentage, right? Do we know how much we're starting off with? No. We want a percentage, right? So why don't we start with 100? That way, whatever we're left with is going to be a percentage. Right? What percentage? The amount left is going to be equal to 100 e to the 60k. 60k. Let's go ahead and calculate this. What is that? We have 1/50 1/50th natural log. Ooh, where's natural log? S natural log of 0.5, and we want to multiply that by 60, right? So my answer is going to be e to the why did I get S? E to the, well, this number, right? That gives me 0.43 times 100. Sorry. Times 100. I forgot the 100.
Well, why don't you just multiply the answer then?
You just multiply 0.43.
Boy, times 100.
What are you doing?
43.527.
So I understand is that
So we have 43.527% left.
so the 100 is there because for percentage, right?
You can start off with it whatever you like there, as long as you interpret it correctly.
What did you do with 60?
Yeah, this is K times T.
Okay, got it, sorry.
100 is my initial amount that I supposed.
How do you know that?
I don't.
You want 60% of the original.
Yeah, if I start off with 100, that means my answer, yeah,
Would this still work if we used another number?
absolutely. But you're not going to get 43.
Okay.
You'd have to do the answer divided by whatever you started off with.
Okay. So that's just like a longer process that you don't want to do.
That is a little bit longer process. I'm trying to play it a little bit smarter here and just put a 100 there. That way, whatever I come out with, it would automatically be a percent.
Okay.
Learn from the best. Okay. Shh. Calm down. Calm down. 60. Oh, after 60 days. Thanks. Okay, that's number 8, right? Why did I double circle 8? What was wrong with it?
Maybe it's just hard.
No, I circled it because there was a typo. Where was there a typo? Wait,
Maybe because it didn't give you the original.
No, wait. The typo was question 3, right?
There was a typo on the other
In
side.
the answer key, right? Number 3?
Yeah, the typo was number 3 in the
Yeah, number 3 and then it's like.
Yeah. It was 81.8 instead of 70, 60.
Okay, there was nothing wrong with number 8, right? Let's take a look at number 9. Yeah, looks like I'm gonna have to fix this again, aren't I? Oh, no, 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 no. What is going on here?
Oh no, you didn't fix it.
This is really bad.
Why?
That's illegible.
You just redo it.
Did you see my face right there?
You look so excited. Why does only one? You can fix nothing stuff. You think that actually you would though. You would wouldn't cut your hair that short.
That's true.
I mean this one I can say. Don't tell my hair.
Okay, I really don't understand, guys. I really don't understand why every time I stop, you have to just have this incredibly detailed conversation and animated and completely. Well, it kind of weirds me out, actually. Number 9. We got 3x squared minus 6x minus 6x plus 9. X squared plus 9, x minus 3. X squared plus 9, x minus 3 equals a over x squared plus 9.
Oh, ax plus b over x squared.
Ax plus b plus c over x minus 3. Okay, so this is kind of a strange question because, well, by the way it looks. And all I can say is you're not going to have a problem like this on the actual final. When you get it, it's going to be more close to what you actually are doing in this class. This is a more advanced kind of integral by partial fractions. Okay, but we're going to do something really similar. We'll start off by equating numerators. Now that looks really intimidating. Because you can't get a 0 here ever. Well, we can start with a 3, right?
Yeah.
Okay, so 3 times 3 is 9 times 3 is 27. 27 minus 18 plus 9 equals, see, 9 plus 9 is 18, see? Substituting 3. Just substituting 3. Just substituting 3. 27 minus 18 is 9. 9 plus 9 is 18. 18 equals 18c, so c equals 1.
So now solve for one of them.
C equals 1. Okay, the next thing you're going to do is substitute another number.
Any?
Pick a good one. How'd I do what?
Do that. Negative.
Because this is 18. 18 equals 18c.
So just divide by 18 and see
Pick a good one.
Zero.
Negative 3.
18 equals
Wait. Can I?
18 equals 18.
Okay, let's go to 0. 9 equals, what is that? 0 times minus 3 is negative 3, negative 3b, plus 9c. Oh no,
And we have C.
I can't solve for anything.
Yeah.
You have C.
C.
Oh, I know c is 1?
Yeah.
Yeah.
So it's not.
Oh, b equals 0. Another number.
Oh, so what? Oh,
1?
yeah.
1. 3 times 1 is 3. 6 times 1 is 6. 9 equals negative 2. A times 1 is A plus B, which is 0, plus 10. C is 1. What is this? Negative 3, so 6. 6 equals negative 2a plus 10. Negative 4. A equals 2.
You can plug in whatever for this last one, right, Mr. Ferrer? 'Cause you have
It would be wise if you picked a good numbers. Good numbers. Okay?
That's all you're saying.
So once you find one, you can plug into the other.
So you don't need to plug it back.
Any questions with 9? Again, the ones that you're actually going to get are going to be a little bit more straightforward than this, okay? Let's take a look at 10. Did we do 10 already? Hmm? I think it's going to be about 40 questions. We did 10 already, right?
No.
The ghost did it.
I know who did it.
I don't know.
Okay, so let's take a look at 10. I'll just kind of explain it as we go along. We have this, of course, starting off. And we're supposed to find the acceleration after 2 seconds. So a couple things you have to go on. Here. Number one, this equation is actually a really poorly written question. And instead of x, they really mean t. And so this question actually gives a y coordinate after x amount of time. So starting off, we need, if we want to find the acceleration in the y direction, we're going to need two derivatives. So we're starting off with derivative number 1. You know, I don't know why there's a box around this. It really shouldn't be a box. I'm going to wreck it. Okay, first job. Take the first derivative. That first derivative is actually pretty easy. There you go, first derivative. I say they're easy, but, you know, not everyone can do this. That's why they don't let freshmen in this class, except for when they let a freshman in this class. No names, no names. Freshman's fine. Freshman got a 5, yes.
Serious.
Okay, second derivative. You need to analyze this correctly. You need to look at it and say product rule. Okay. So look at it and say product rule. Good. The derivative of 3/2 x squared is 3x. And then we're going to take the second factor and leave it alone. Plus, now we leave the first factor alone and take the derivative of the second factor. The negative 1/2 is a power. The power is decremented to negative 3/2. The 3x squared is the derivative of x squared plus 1 because you need a chain rule to take this derivative. I'm going to pause there for 1 second, and then we're going to move to the next line. Okay, the next line is a simplification. That first term, I can't really simplify much, but the second term, I see a negative 1/2, so I'm going to take that negative and stick it in place of the positive. I have 3/2 times 1/2 times 3. That's 9/4. So I get 9/4 x to the 4th power times that whole junk to the negative 3/2 power. Pause here. If you have a question on that part, let me know. Otherwise, I'm going to move on and be upset when you ask a question on this line again. Questions on where we are? Okay, next I'm going to factor. And I'm going to factor a couple of things. The first thing I'm going to factor is 1/4. The second thing I'm going to factor is x. And then the third thing I'm going to factor is least power, which is that junk to the negative 3/2 power. That's this right here, common factor. Wow, this isn't algebra anymore. You're factoring out 3 things at the same time. It's really good thing you're the cream of the crop, because I tell you, my regular algebra kids, they're not doing this.
This was like a joke.
Okay, so we got 3x divided by 1/4, that's a 12. The x, of course, gets factored out, and if I factor out a negative 3/2 power, the negative 1/2 becomes the first power. Okay, if I factor out a 1/4, then 9/4 becomes a 9. And then the x, of course, instead of x to the 4th, it's decremented to x cubed. And the junk is factored out. Questions on that? Okay, I'm going to assign each part as either numerator or denominator. Okay, this 1/4 is actually a 1 on the numerator and a 4 on the denominator. This x belongs in the numerator. This negative 3/2 power belongs in the denominator. And all of this here belongs in the numerator. All right, so my numerator has an x and then this parenthesis. I'm going to expand the parenthesis. Here's the denominator 4 and then the 3/2 power. Not yet. Then I'm going to go over here and I'm going to simplify the numerator. Factor out a 3. And that's the second derivative. Aha. Now I know why we had that box.
You could have done it in your calculator.
Yeah, this is actually a calculator question. There's no need for us to actually take the second derivative by hand.
Oh.
Stop. What? What? Wait, what? Stop. How did you? Okay, so you teach me how to do that?
Okay, so let's remember some calculator stuff here. Calculator stuff. Okay, wait. Calm down. Okay. Let's get finished with this and we'll talk about the calculator. Okay. Unless you paid an extra $50 for your calculator will not find the derivative for you. Okay? So if you spent the extra $50 in the calculator, you know which calculator you have. Okay. So let's do something else. Your calculator can actually find the derivative. I'm sorry, cannot find the derivative, but your calculator can evaluate a derivative. Okay, so let's evaluate a derivative so you know what I'm talking about. What's the derivative of x squared?
2x.
If I evaluate the derivative at 1/2, what's the derivative of x squared evaluated at 1/2? 1. Okay, I'll show you how to do this on your calculator. Okay. Please don't do it right now, just watch me. I'm looking for the function called looking for the function called nderiv. Alpha f2 nderiv. If you have a TI-83, then you would go under math. I think it's number 8. So the first thing I want is an x. That's ddx. I'm sure you know why. We want derivative of x squared. And we want to evaluate that when x equals, we said 2, right? Boom, 4. No, we didn't say 2. We said 1/2, right?
Is this just an example?
It's just an example, yeah.
Oh, I was like, wait.
1/2. Do you see a second derivative anywhere here? No. That should let you know. There is no, your calculator does not do a second derivative. It can only do one derivative. So if I want the second derivative, I still need to take the derivative, right? So what I'm going to do is I'm going to plug the first derivative into here and then evaluate it at x equals 2. So let's take the first derivative. Okay. Go ahead and put n deriv on your calculator. You want a ddx. And then the function you need here is the first derivative. What was my first derivative? 3 over 2? 3 over 2. What's next? X squared. Oh. Hold on. We need a parenthesis, right? Times the square root of x cubed plus 1. Is that right? And I want to evaluate that when x equals... Where's -1?
Like the x plus 1 is to the -1 now.
What? Oh, it's not to that power. Sorry, I pushed the wrong button. Don't be alarmed. And I need to go to the negative 1/2 power. Like that?
I don't know errors. I get the answer. Then I did plugging in the 1/2. Like the unsimplified.
Oh, I got that. 0.666.
Yeah, see, I got that, but like, I got that when I plugged in like 1/2 x cubed plus 1 and then 1/2 times 3x squared. When I plugged it in like that, I didn't get it.
When you plug in where?
Like, okay, scroll down, like the picture that you have right there of that, when I plug it in like that, I get the 0.666. When I plug it in with the 3 over 2 x squared, x plus 1 negative 1/2, I got 2.886.
You'll have to show it to me. Not now. Okay. Any questions with 10? You know, we're not really all that close to finishing yet, so.
Oh, wait.
Finishing 10?
Never mind, I know what I did wrong.
No, because we have 11, 12, 13, 14. We're not really close to finishing. Let's take a look at 11. We want to, sand is falling off a conveyor belt into a conical pile at a rate of 15 cubic feet per minute. The diameter of the base is twice the altitude. At what rate is the height of the pile changing? When it is 10 feet high. Good. What kind of shape am I looking at here? Cone, good. Let's draw a cone. That's not a cone. Yeah, that kind of looks like a cone.
Oh, I understand that. Get a cone the other way. That makes more sense though. The pile, huh? Yeah.
It's a pile of sand. Haven't you ever watched like a? Don't you ever hang out at the rock quarry and watch the conveyor belt dump sand into a cone?
Yeah.
My cousin used to live next to a rock quarry. Yeah, and we used to go and hang out at the rock quarry and watch the conveyor belt. No, are you kidding?
I was like, seriously? You guys really tore up the town.
Yeah, you know when you live in San Dimas, there's not a whole lot to do.
That's why I was like, what the heck? Why would you even do that?
Okay, we know a few things about this cone. The first thing we know that is the volume is equal to 1/3 of pi r squared h. You should definitely know that. Okay. We also know that the diameter is equal to twice the altitude, right? The diameter equals 2h,
Altitude's just the height.
which means 2 times the radius is 2 times the height, which means the radius is equal to the height. Okay, I want to find dH dt at the end of this, right? So I'm going to substitute out all of my r's. Volume is equal to 1/3 h squared times h times pi. Or the volume is equal to pi thirds h cubed. Awesome. dV dt is equal to the derivative with respect to time of pi thirds h cubed, which equals pi thirds h squared times dH dt. You know I'm forgetting something here, aren't I? I'm forgetting to multiply by 3, aren't I? I'm a little alarmed.
Whoa! How was that?
Just do Command Z.
Yeah, they can.
Control Z.
But
Oh, yay!
okay, that's my dV dt. We want to know dV dt. Do we know dV dt?
15.
dV dt is 15. Yes, you're correct. 15 equals pi. Do I know what h is? 10. Good. 10 squared dH dt. Let's see. 10 times 10, that's 2 squared times 5 squared. One of the 5, so that's 2 squared times 5. 15, 3 times, so 3 over 2 times 2 times 5. 4 times 5 is 20. 20 pi?
Did you do that funny?
No.
15 over 100.
You have to divide
Just 3 over 100.
55 over 100.
That's equal to dHdt.
So plug in a derivative first, then plug in the rest.
On the test, are the answers going to be in terms of pi? So,
Maybe.
just either way.
Did I actually get that right? 3 over 20 pi, yeah. I took a risk there doing it in my head. See, the problem is I'm trying to get better at mental math, and you're all held hostage to my trying to figure things out that way.
I agree.
Yeah, okay. I'm keeping the recording on here. Do you need the key? You need to open it?
Under the key for all the
Wait, no, this is to the bathroom.
This is teachers.
Teachers.
Okay.
Okay.
I'm going first because I have the key, so.
Yeah, there are 2 bathrooms, one on each side. The men's side's probably disgusting,
Okay. Even with teachers, I don't break.
especially with teachers. That's gonna take more than 2. That's not gonna take more than 2 minutes, Sarah. Play. Ooh, play. The guitar is bigger than you.
Oh,
Yeah. It's like bigger than your mind. Bigger than your
What you see? Are you studying for this Friday?
We'll go with the amendment. She asked us the question on the amendment.
Are you studying for this Friday?
It's a bad question.
Is it?
Okay. Bad question. It really should.
Are you in my? I was talking about physics.
The exam. Did he put it in?
That's gonna be second.
I love this.
Funny if it was actually in drawing.
Are you waiting for me to
Should I be happy?
Everything that's else.
I want him to clean the process.
It's at home. Where do you want to keep them? Where do you want to keep them?
America.
So, And they really gotta say that.
I'm locking out on you. Fine, thank you, Brian. Brian got me a car.
I've never seen the guy. I know what you're talking about. I saw that. That's literally the first line. Oh yeah. I didn't know.
You're gonna get bad. You're gonna get bad cards. You know what I'm nice is that you're gonna get bad cards.
Are we all back?
Yeah.
All right, let's go. Let's do this. Okay, 12, 12, 12, 12. Let's finish up, please. You guys have a long night of studying. Have to go to K-Town. All right, 12. 12 is actually not that bad, not as bad as you might think. 12, you need to find the area enclosed by those two curves. The problem is that these are not functions in the traditional xy plane. So in order to solve that problem, you're going to reflect, which is a mathematically proper way of saying, I'm just going to switch all the x's and the y's. Okay. So I'm going to switch all of the x's and the y's. And I'm going to solve for y again. And then I'm going to graph. If you do it all correctly, you should get these two graphs. You get a line and a parabola, an upward opening parabola. And I'm going to pause it right there. Make sure that you get to where we are.
But you just said Valerio.
No, for real. Instead of reflecting, can you just solve for y?
If you really want to do it that way, yeah.
Like square rooting y squared.
If you really want to do it that way.
I'm confused.
How do you plug it into? Oh, just kidding.
How do we graph?
Not even the same person.
Okay, everyone, please. Any questions about producing the graph? If you did not do it this way, you're going to get a graph which is kind of reflected and sideways. Okay, next thing is you need to find the area inside this little part right here. So actually, this is a good time to talk about your quiz. Because the intersection point was not neg 1 and 2 or whatever you're putting.
1.82.
Yeah, it was 1.8 and change.
Yeah.
And if you did not put that in there, you really didn't get good points.
Oh yeah.
And then like 2.7.
Yeah. Okay, so if you did, anyways, you did not, if you didn't do that, if you just assumed that because it looks like 2, it was 2, you probably didn't do that great of a job. Now, the next thing is we need to find these intersection points. Again, this looks like about -4. This looks like about, I don't know, +4. But I can't actually say that it's definitely those two numbers. So what I'm going to use is I'm going to use the intersection. Okay? I feel pretty justified in this because we've been using intersection like almost the entire semester. So hopefully you'll know how to find the intersection of the two curves by now.
Okay, how do you do this?
Second calc.
Second time.
Second calc. There's 2 points of intersection now. So
You're right.
Oh, okay.
We've taken care of that problem too. Okay, our intersection points, A equals -4, B equals 5. Okay, so that's -4 is the x-coordinate here, 5 is the x-coordinate here. Now it's just a matter of integrating from -4 to 5. What's nice is your calculator, if you actually have the functions in your calculator, you can just use y1 and y2 to shortcut that integration so you don't have to type a whole lot. So we're integrating from -4 to 5. My red curve is y2, my blue curve is y1. So y2 minus y1, you're going to get 30.375.
Does that say -4? Yeah.
Yes, that's it for question 12. 2 more to go. We want to find the area in the region in the first quadrant bound to on the left by the y-axis, bound below by the line y equals x, bound above by the line y equals 1, and bound on the right by the parabola y equals 1/4 x squared. So I think I'm going to graph this on the calculator, even though it's really an easy one to graph by hand. So let's graph this. The first one is, of course, the y-axis, which I'm not going to bother with. Next one is the line y equals x. All right, there's y equals x. And then the other one is 1/4 x squared. 0.25 x squared. Now I'm pretty sure I only need the first quadrant. So I'm going to go ahead and try to be smart and only look at the first quadrant. which means I only need an x minimum of -1, x maximum, let's say it's 5. Let's do the same thing here. Y minimum, let's make it 1. X maximum, let's make that 5. And I'm only doing this because I know I'm supposed to be in the first quadrant. Let's graph. Okay, that box, I don't want it there. I think that's from statistics. So I'm going to go over here to y equals and take a look and see how plot 1 is highlighted. That shouldn't be highlighted. I'm going to regraph. And that should take care of the box. Oh, I'm supposed to have y equals 1, aren't I? Y equals 1. Here we go. Okay, so I see a few different regions here. Let's count them. I have this one here, this here, this here. That's 3 different regions. Actually 4 if you count this one over here on the left. Well, the question should be, which region do I need an area for? 1, 2, or 3?
Wait, so 2.
I don't know, it has to be above y.
Or yeah.
Oh, above, right by 1. Below. Yeah, it has to be above y. Above y, right? But below the y.
That one, where your cursor is.
Yeah. And above the right.
Because there's also.
Wow, this is kind of weird. It says that the region should be bound to the left with the y-axis. Okay, so the y-axis is supposed to be a boundary curve. It's bound below by the line y equals x, so it's supposed to be above the blue line.
Above the blue line?
That's what it says, right? It's bound below by the y equals x.
Yeah.
So if the lower boundary is y equals x, that means it should be above y equals x.
Right.
Okay. It says it's bound above by y equals 1. That means it's supposed to be below y equals 1.
What? Oh, okay.
And then above right by the line y equals 1/4 x squared.
Above right. This is a poorly written question.
Again, this is a pretty poorly written question.
Did you write it?
No?
No. Or who writes this thing? Practice.
So, yeah, I don't know who wrote this question, but if I was going to redo this, if I was going to make this question, I would imagine what the region that I really want is this one where my cursor is right here.
Did they want the triangle? Like in between?
But they want above y equals 1.
Why would they want the triangle if they got it above?
And above y equals 1.
Or it could be above. There's so it's 3 places there.
just right here. Yeah.
Okay, so let's just go with that assumption, and I'm going to fix this one for next year. Fix. I'm going to write the words what over it. And let's just screenshot this. I'm going to go ahead and zoom in over here again. I don't think I need the x max to be more than 3. I don't think I need the y max to be more than 3 either. Let's graph that again. Awesome. Okay, I'm going to screenshot this for number, this is 13, right?
Yeah.
We're going to need a little bit of room here. Okay, and, oops. Okay, let's put that in the notes. And maybe we should write down what we said here. This question is poorly written. Okay. We want the area of the region shaded below. So let's shade in that region now. Luckily, I have a highlighter. Wait, I have a tablet. I can use the tablet to give me even more precision.
Oh my goodness.
It's amazing what they can do with technology nowadays. We want this region right here. We want that region right there. Okay, let's get some intersection points. What is this intersection point there?
0, 0.
What's this intersection point right here?
1, 1.
Are we sure it's 1, 1 exactly?
Yeah.
Well, it is on the line y equals x. The x coordinate is equal to the y coordinate there. How about this one right here?
2, 1.
2, 1? Okay, 1/4 of 2 squared is 1.
Yeah.
Yeah.
Yes, it is. Okay, good. So we have our intersection points. We want this one. Now, take a look at this. What happens right here?
The top curve change.
Yeah, the top curve is going to change. So from here, from 0 to 1, it's going to be blue minus red, plus the integral from 2 to, no, from 1 to 2 of black minus red. Okay, are we good with the plan? Bye-bye. We're going to integrate from 0 to 1. What's the equation of the blue curve? Y equals x. What's the equation of the red curve?
Y equals 1/4 x squared.
Plus the integral from 1 to 2. What's the equation of the black line? What's the equation of the red line? Can we integrate this? What's the integral of x?
1/2
What's the integral of 1/4 x cubed? X squared. Plus, what's the integral of 1? And then we know that's 1/12 x cubed, right? From 1 to 2. Great. This is good. Let's see. We have 1/2 of 1 squared minus 1/12 of 1 cubed minus, okay, that's 0, plus 2 plus 1/12 of 8. Let's say minus, you're right, minus 1/12 of 8. minus minus 1 minus 1/12 of 1 cubed. Now I'm a little suspicious because I think things are going to cancel out here, but I want to make sure. No, it's not going to cancel out, is it? No, not. I got 1/2 minus 1/12. What? Oh. Plus 2 minus 8/12 is 3/4. Minus 1 minus 1/12. Wow. Everything has a common denominator of 12, yeah? Okay, so let's do this as over 12. 6/12. Wait, this is a calculator question.
I can't do this anymore.
Can we just keep going?
Yeah.
Couple more to go. No, it's
All right, did I get that all right?
wait.
6 minus 1 is 5. 5 plus 24 is 29. 29 minus 9 is 20. 20 minus 12 is 8. 8 plus 1 is 9. 9/12. Okay, I'm actually going to do this on the calculator too.
The answer is 5/6.
Yeah,
Oh, it's not 3/4, it's 2/3.
it's 2/3.
No, on there, look up. You see 9/12?
5/6.
It's not 9/12, it's 8/12.
That's
8/12?
that's 2/3.
So it's 2/3.
Oh my god, we don't decide.
No, not the answer. The answer is 5/6.
Oh, it's just a block.
No, the answer is 5/6. That was 2/3.
To the right.
5, 29,
That's
20,
8. That's
8. No, that's 9.
No, if you look up, it's not supposed to be 2 minus 3/4. It's supposed to be 2 minus 2/3.
2 minus 2/3?
Yeah.
Yeah.
So it's 6, 7, no, 6, 5, 29, 21, 9, 10/12.
10/12, 5/6.
Yes.
Okay. On the calculator, let's do this on the calculator. Gonna clear off, of course. Okay, I'm gonna integrate from 0 to 1. What was that? X minus 1/4 x squared, x cubed. Help.
Yeah, last one.
X squared
No, we're not. Never mind. We're doing the other. We're doing this one. Yeah, we're doing this.
plus integral from 1 to 2. 1 minus 0.25 x squared dx. 5/6. Okay. Again, only doing this so that's in the notes, but so sorry, I totally forgot that this is a calculator section.
It's all right. It's okay. That's okay.
Totally forgot.
I'm definitely gonna do that on the test. Yeah.
Okay, this is fine. There's no problem anymore. Questions?
We're doing 14?
Let's look at 14.
That's fun.
Last one.
Now it's a big system.
Coming in about an hour. Okay, so the last question we're looking at, we should graph it.
Oh, yeah, I was right.
We should graph that. I know you think you're whispering, but really my ears are so good. Which is really funny, actually. My ears are horrible, but I can totally hear you. Negative x squared plus 3x. Negative x squared plus 3x. 2x cubed minus x squared minus 5x. Great. This time I don't actually know what the graph looks like, so I'm going to go ahead and do this in the standard window. Okay, so zoom standard. Zoom. Standard is number 6. And that should get me something which looks interesting.
Yeah.
Oh, that's tricky.
Ooh. Do they intersect down here?
Yes.
Yeah, I think they do. Okay, maybe we should adjust that window a little further down. That's the y minimum. Let's make that 12. Maybe that'll show me the intersection point a little bit better.
Go to page 396, number 13.
Okay, so is it the shaded region on the left or the one on the right?
It's in the book.
It's
It's negative 2, negative 10.
yeah, it just says find the area of the shaded region, so can you do both?
I think we have to do both here, right?
Yeah.
Okay, so we're going to have to get these intersection points, right?
Yeah.
Let's find our intersection points. Second, calculate. Number 5, intersection. Okay. Let's scroll over to the first intersection point. Push enter a bunch of times. And then we have at negative 2. So let's try to remember that that intersection point's negative 2. It's nice because it's an integer. And let's get the other intersection point. And this next one is 2. So we're going from negative 2 to 0, and then from 0 to 2. Let's kind of take a look at the way that looks, and maybe I should screenshot that too. Okay, let's screenshot that.
Wait, the other one is 2? Yeah, it's like yeah.
Let's take this and right, so let's kind of write down our integrals. What's going to happen? We're going to take the integral from negative 2 to 0 And we're going to do the red minus the blue. Right?
Is your red one like the 2x cubed?
Yes. Then we're going to integrate from 0 to 2, and we're going to do the blue minus the red. You know how when you look at a word long enough, it starts to look funny?
Yeah.
The word blue looks funny to me now.
Yeah.
I can do that.
Kinda green.
I disagree.
That might be it, actually.
Haha, man.
That might be it. Okay. Let's see. My red one is y2, right?
Yeah.
So if I go to the calculator now,
Which one's the red?
my red one is y2. So I can integrate.
2x cubed. Yeah. Minus 5.
That's the wrong menu. I can integrate from negative 2 to 2. Negative 2 to 0, yeah, thank you. Negative 2 to 0. It's going to be y2 oops, wrong one. No, that's not it. y2 minus y1 dx alpha f4.
How do you get the y2 and the y1?
Yours is going to be vars y vars function. Bye bye.
Vars, function, y1. Gotcha.
Integrate then again from 0 to 2. y1 minus y2 dx. Because it's a calculator section, that's fine. 16 sounds like a reasonable estimate.
Oh, y1 minus?
16.
Is y1 minus y2 again? Yeah, it switches.
Okay, that is that.
Yay!
Have a nice day. Good evening.
About this question, so if it says bound above, so we consider it.
If that's bad, don't read it. It's bad English.
No, because I already have a question last days. It's something like this,
Yeah.
and you
Bound
said
above means it's below.
So it's good for this one.
Yeah.